the IntelliJ IDEA video, I will be talking about debugging, starting with the very basic stuffs, and later I will showcase some more advanced techniques to reproduce bugs and stuff like that. So why debug in the first place? Basically, I use debugging for almost all aspects of programming. So, for example, if I start working on a new project or something, then I have to understand the code base. And one of the fastest ways to do that, if you read the code base and you also debugging it in the same time, so you can check how the process calls and the data flows going, and you can do that by debugging. Another useful case is when you want to finding bugs and fixing bugs. So when you actually saw what's in the memory or which variable takes which values, it greatly increases the chance that you are actually understanding what's causing the bug. A bit more advanced use case is when you want to change the behavior of the code in runtime. So you have, for example, an if-else phrase, and you want to override how the program runs next. So you can do that as well. You can add some temporary logging, which is also useful if you don't really want to pause your application, but instead just want to add logging without actually modifying the code or the production code. So these are the main use cases of debugging, and let's look into it, how we do that. So a general thumb rule of mine is I always start every application in debugging, because that way I don't have to restart the application if I want to check something, which can for big monoliths can take a lot of time. So we can start any application or test or anything by debugging by pressing the debug button instead of the simple run. So for example, I have this simple test case here. I can run it in debug mode, and it will just run fine because I don't have any breakpoints. To place breakpoints, just go to the line and click on there. It will place the breakpoint, and you can remove those. You can mute your breakpoints. So if I have a breakpoint here and I run it in debug mode, then it will stop at the breakpoint. But if I don't want it to stop the breakpoint, then I can mute all breakpoints. So I don't have to remove them, but I will still have them. I can check where I put my breakpoints by pressing Ctrl-Shift-F8. Here I can check all my breakpoints. I can even group them, and I think I can, maybe it was a plugin, but I guess you can somehow export the breakpoints and import them. So if you have really a lot of them, because you are trying to trace down some nasty bug, then it can be useful to categorize them. So you can disable and enable them by groups. So when you have a breakpoint, what you can do is it's interesting. Not sure what exception was that. Anyway, so when you have a breakpoint, you can you have these operations that you can step over, which will basically just jump to the next line, obviously executing the code which was before. You can use the stampede too. So I'm currently standing on this line. So if I press F8, then it just jumps to the next one. But if I want to go into the getCounter method, which is not really shown here because I'm using Lombok, But if I just press F7, then it yeah, it should jump into the getter to make it more presentable. I just generate the actual getters and setters. So now if I want to go into the counter, I press F7 and it goes into the actual method. Then I can just press F8 here to move to the next line, which is actually stepping out from the method because that's all it has. But if there would be more content in the method, this you don't really want to add extra stuff in the getters, but for the demo's sake. So if I jump into the getter method now, for example this getter, then I can just move to the next line with the F8, or if I'm not really interested in the, I don't want to step all the way through, then I can use the step out, which basically just runs all the remaining code and goes back to where it was called. You can just move on. You have this run to cursor, which I'm not sure what it's doing. I'm rarely using that, or not at all. So yeah, that's the basics how you navigate with breakpoints. So I often see that people are doing this, and they are just pressing, to release the breakpoint you just press F9, resuming the program. So I often see people just doing this, that they place breakpoints everywhere and pressing F9 where they want to stop, but actually you can control it by yourself, so no need so many breakpoints. So this is the basic stuff, and how you navigate with breakpoints. What actually is interesting is what you can do when you are standing in a breakpoint. So currently you are standing it here, and in the memory you have the this class, which is the base class, and once I'm creating this local variable, now I can access this as well, and I can even change the value of it or just observe its value. So if, for example, if I'm not understanding why this one of my method is not returning what I want, I can just check it here, or even I can change the value. So for example, now I just changed the value of the p1 counter variable. What you also can do is press Alt F8, which opens the Evaulate expression menu, which is useful. Basically, you can write any kind of code here that you would be able to write at the point where you are standing in the code. So for example, I can write that p1.getCounter, and I can evaluate the result of this operation or function call, and this way I can I don't have to write physical logs and stuff like that into the code to have me understand it. Instead, I just put a breakpoint in the right place, and I just call the stuff I need, or I check it from the debug window. Keep that in mind that if you have a code which has side effects, so for example this increase counter increases the value of the counter, and you call that from a from this evaluate extraction. It's actually a void function, so it's not returning anything, but you can see that in the background the counter value is increasing. So keep that in mind, that yeah, you can change the behavior of the running accidentally as well while you are evaluating expressions. You also can evaluate expression by holding Alt and clicking. Of course, you can only do this at if the actual variables are already existing. So, for example, if I start to debug this again, then I can evaluate the P1, which is the class we just created. But for example, I can't evaluate this P2 because we are not yet reached that part of the code. We have in the debug window, we also have this call frame. So I guess this is just the coverage data which I accidentally ran. So like I place a breakpoint here, which we should reach by typing 100 into the. Actually, we can type anything, I guess. Yeah, so we run this test, or this, it's actually an application. So now it's standing probably here. We just type in 2, then we should stop the breakpoint, and here is the stack trace, which, or what is it called? It frames windows, and we can backtrace from here how we reached that breakpoint. So we started from the main method, we jumped into this method, then we went through this method, and we went to this part of the if else, and here we are. So this is why debugging an application in runtime can help understand how you go through, for example, when you call a business method, what's happening, and yeah, which values are going to, which methods are going to execute it, which are not. So we can backtrace like this using this part of the code. One thing that we saw a lot more in this frame, because it's marked with yellow if you are calling some sort of code which is not in your project, but it's still getting called. So usually the library calls are marked yellow, and the reason behind this is your actual code is not starting here, or your code is starting here, but the running is not starting here, since this is a test, and to run a test, you can just backtrace it what's happening. So it starts from the JUnit starter, and I'm not sure where you can be able to step into it, but yeah, you can just debug through what's happening when you are run a test, and these are all the stuff that happening before your test even gets to executed. So yeah, you can debug libraries as well. So if you open a library, and I guess I have the sources downloaded here as well, but you can break points here in the libraries as well, and if it gets called, then you can stop in places outside of your code. So it's also useful. What else? So it can help us with with reproducing bugs. So for example, if I'm or just observing behavior, so let's just get a so for example, if I want to reproduce a null pointer exception, then I can just override the value in runtime with debug mode, change the value to null, and our next part of the code, which relies on not having a null value, will be failing. So for example, here, if I override the string value, then no matter what kind of input I give, so I'm running from here to here, but I can just say that you should be null, and it's already giving me a warning that this will throw a null pointer exception. And if I just continue the code with the F9 or F8, whatever, I get a null pointer exception. So this way I can check the negative path of my code. For example, how the front end would react to something like this without too much hassle. But if I don't want to step into the breakpoint and stopping the running, so if I don't want to do this manually all the time, that set value, then what I can do is, and this is where the fun part begins, I can just right click on this and take off this suspend, which basically tells the IDE to stop the running at the breakpoint. So if I remove this, then the breakpoint, if it gets hit, it's not stopping, but what you can do is evaluate into the log anything you want, which you would be able. So it's basically the same as when you press Alt F8. What you can write here, you can write in the evaluate to log as well. So for example, I could just print out the value of the input parameter. So yeah, we can see that it's logged out. But I can also execute code here, so I can say that I don't want to evaluate this string. I want to evaluate that let's be equal to null. So actually this is going to be executed, and it will be overriding the s value. So yeah, this way we don't have to stop the program and do this assignment by manually. Instead, we just can do this, and if I run the code, press 2, then we boom, got our null pointer exception. So this is one way to alter the flow of the program. We can also give conditions. These are useful when, for example, we are running on a loop, or we are just only interested in on certain conditions. So I can do that. I only want to debug this main flow method if the parameter is this. Obviously, this makes not much sense, since the next I could just put the breakpoint here, but for the sake of the demo, I can just type that equals this, and I run it in debug, and I type in 1, then then it's stopping. But if I type 2, then it will pass this, and it's obviously not this, so it's not stopping at the breakpoint. If we accidentally remove the breakpoint, just I did, and then we can restore the previous breakpoint by placing the breakpoint, not by double placing it, but if I have a condition here, like this, and I accidentally remove the breakpoint, and I can restore it by clicking it there again, and restore previous breakpoint, and it will restore the conditions. This can be useful if you have really huge conditions here. Also, you can tell that should it suspend all the threads in your application, or just a given thread for that flow. Most of the time you are fine with suspending all of the thread, but if your applications has other crucial threads which really don't like to be hanged, like if you are connected to another server or something which has a timeout if you, for example, they don't exchange health checks or something within every 30 seconds, and you are standing in the breakpoint and checking your stuff more than 30 seconds, and you get disconnected. So to prevent that, you can just swap to threads to stop only the thread. You can use filters like I actually never use them, but I'm sure there is a use case for them. So you can filter instances, and under instances you have to type the. I don't really have any object here, but if you would have an object, just search an object. Where was that? I'm using this. Oh, it wasn't the test files. So now I have an object here, actually multiple. So I have this Bojo class, and I can filter by this ID. So, for example, I'm only interested in this get counter call if it's coming from if the ID is this. So I could just write that ID here, and it would only stop if that exact instance is calling this. So you can tell that the breakpoint should be removed once it's hit. I will show you an example where it's useful. So to give it more real use cases for this, what you can do, for example, is let's say you want to log your SQL's queries, but you don't want to restart the application to reload your configurations. So you can, by default, so you achieve by applying this config. But yeah, if you change this and you don't have auto reload or something like that, and then this change will not take effect unless you restart your application. But let's say you don't really want to restart your application, and here are the tricks that you can use. So we went through the last time where this value is actually used. So let's just say this is false or not present at all. But I still want to log my, let's see, I don't really debug logs. So this is where it is used. So for example, when I'm calling this, it should call a repository call, and I see nothing. But if I go here, I take out the suspend, and I evaluate the log that obviously the out should be true. I don't say this for now, but then in theory I should be able to see the logs now if I call this. And yeah, here are the logs, since I just changed the value of this condition to true. So it's almost the same as if I would have the configuration here, but I did not have to restart the application this way, and I still see the logs. This is useful when you have you are trying to reproduce a bug, and you have lots of preparations to make in runtime by clicking or something like that, and you just don't want to lose the progress by restarting the application or stuff like that. So as you can see, it's actually evaluated all the time. It hits this point, but in theory you only should change this once, because it's not global, but it's a class level variable. So here is when this came into play, that remove once hits. So it will just run once the breakpoint, and we should no longer be able to see these trues here. So let's just clear, and if I click here, then yeah, it's only called once and no longer. So what else we can do? We can go further. So for example, I'm only interested in the update queries. So I can just add an owner. Let's see. We have some other breakpoints somewhere, which it's an actual log somewhere. Yeah, we are actually logging this when we are adding something. But yeah, so when I edit this owner, update the owner, and there are a lot of queries are getting executed, but we are only interested in this, for example. What I can do is I change this, and let's say the statement contains the value update, and in theory it will only log the updates. And not sure what's missing. So let's just actually make a real breakpoint here, and yeah, so we have a select statement and we have an update statement. So statement contains true. I might have the remove once hit enabled, and I guess that caused the problem. But let's see. So evaluate the log. Right, so we only see the update now. Of course, now we executing that sort of line every time we run through it, so that's why these all true falses are here. Actually, we can track our overhead. So we have this debugger, and we have the overhead window, which can be enabled here. And we can see that how much time actually our breakpoint takes. So if you write conditions in loop statements and stuff like that, it can be pretty costly. So this is for monitoring that. Also, we could have done this by just simply not filtering the statement, but filtering the actual log with the. So now we have lots of logs, and we just can grab this one. But yeah, with this way we can add quite more complicated stuff. Another example which I used recently is I needed to reproduce a deadlock situation where two methods, one was a get method and one was a post method, reach the same sort of logic, and it had a typical deadlock scenario that one requires this log, the other requires the other log, and but in different order, and they just stuck. And to be able to reproduce that without changing the code, what I was done is I'm gonna use the other application. I was placing breakpoints, and I sleeved one of the threads only if it's a get method. So I would have the time to manually call the other method, and I sleeved the post method with a different value, and that way I could time the deadlock every time I wanted with ease, without actual code change. So how to do that? Let's say I'm searching for the controller. Yeah. So let's say I have this method. I have this breakpoint here. So if I call, if I start the application, and I call that and I should stop at this breakpoint, and I can see that not much is here. But since I'm running in a Spring Boot environment or framework, I have many more things in the background. So I got probably a running Tomcat embedded web application and a lot of other stuff, which also causing this long stack trace. So how can I receive the request? So for example, how do I know if it's a get request or something like that? I could expand the parameters here to include the request and stuff like that, or I can just ask the ChatGPT or manually debug it myself, but since we have this is much more easier now, so I don't really have to go through all the hassle. But in the end, it tells me that I can just fetch the request from static context. So I just press Alt F8, and I'm looking for the request context holder, which is a static class, I think. So I'm getting these attributes, and I'm getting the request from it. and boom, I have the request, and I can just get the get method, and I'm having that this is a get method. So if I would be deep in the code where the deadlock situation should happen, then I could just place two breakpoints. Let's just imagine that this is the deep part of the code. So I could just take out the suspend. I could just put here the condition that get request plus get method equals method.get.toString. So I'm having this that not sure what's its problem, but yeah, in theory I might have this saved. Yeah, this should work. So so I'm only stopping in this breakpoint if this whole process is started from a get request. And if it started from a get request, I can just, let's say I want to sleep, and let's just see if it's working. Yeah, so it's working, it's just not sure really the best. So let's showcase this way. So I'm pressing the method call now, and it's actually waiting the 2 seconds. So it's working as I expected. But yeah, for my post method, I would just put a different breakpoint somewhere slightly off, and that would just get put. And we can see that this way it's not getting executed. So this is another smart way to really utilize this evaluate to log or to the conditions. So you can really be creative here and put all kinds of stuff here. The only downside of this is that you kind of forget to add the real logs to your applications, because you just put breakpoints everywhere, log the stuff you are interested, making sure your program works, then you just remove the breakpoints. But yeah, you are kind of losing the logs as well. So that's the only downside I noticed. But aside from that, it's really powerful that you don't have to keep restarting your application and changing the code. Instead, you can just do a lot of stuff from here. Also, another great stuff which is related to debugging and Spring Boot is hot swapping. So, for example, now I have my code running in debug mode. The prerequisite for this is that you have a Spring Boot project which has a dependency called name. Not sure if it's actually needed or not. Spring Boot Devs Tools. I think this should be needed for it, but let's see if it's works without it. So what I want to showcase is that you don't have to restart the application if you are changing the code. You can hot swap. So you have this debugger hot swap, and it has a few configurations. What basically it's doing is that I have my controller, I have this code here, which if I call this method, it will print out this or this. It's now writing this, so if I call this and it write out this. But if I change this to something different, then I call this, then still this is the old code is getting executed. But if I build a project, then it will show that one class has been reloaded, and actually this is the hot swapping. So I'm not sure if it's the IDE stuff or the Spring Boot stuff, but it noticed that one class was changed, and it can be replaced without restarting other parts of the program. So it will swap out that class to the new class. So now that if I call this again, it will be the different part of the code. So now it's actually this one is executed. This is also a really useful feature when you are creating new code and you are just trying to figure out the logic. Since as long as you don't create new methods, or the general thumb rule is if you are not changing the structure of the code, but you are just changing stuff inside the method, then hot swaps should work. But as soon as you are, I don't know, adding new annotations or just renaming methods, I think this is also not going to work. So this is, or adding a parameter, those are no longer be able to be hot swapped. So if I build a project, it says hot swap failed, and in this case you actually have to restart your application. But as long as you operate inside of a method, then you are free to change anything, and you can just build a project and yeah, the hot swap will happen if you have that options that you want to replace it. What else? You can place you can add the special breakpoints, like in the breakpoint menu we saw this part that Java exception breakpoints. So for example, I can add the Java exception breakpoints, null pointer exception, so I don't have to backtrace my null pointer exception. Instead I can, because sometimes the stack is not actually containing where it's originated from, so I can add these kinds of breakpoints, which will stop if a null pointer is happening. To showcase this, I have for example, here, if I pass this, then I probably have a null pointer exception. So let's just start this in the debug mode. I don't have a breakpoint anywhere. It'll be in 100, and yeah, the null pointer exception is happened, and it's stopping at the exact same spot where the null pointer exception would happen. So it's actually stopping before it's happening. So yeah, this is also useful stuff to trace down exceptions. And we have a few extra stuff, like I don't know, sure why. Oh, because I started coverage. So we can add the watches, which basically are we just extending this list, but I guess I can't add here the last showcased stuff like this, but I could add the watch for this, and it would always display the value here of the current method call. That what type of method was it? So I don't have to every time evaluate that expression. Instead, I can just create a watch for it. Also, I have this data views, which is I can override, for example, how date objects should be printed here in the debug part, or when we have these evaluations here. For example, if I have I don't know what kind of date time, but some of them are pretty unreadable, then I can just define a type render for it, and I can write my yeah, I used it a long time ago, but yeah, you can create a data type renderer here, so you could format it and display it in a readable way without changing the code. So that's a nice feature too. Or if you have forgotten to add the toString methods for an object and you want to still read it without restarting the application. Yeah, so that should be the interesting stuff about debugging. And these are the stuff I use the most, especially these Evaulate logs. With this, another nice trick is to just get some really unique prefix you want, and you just can use the grep console to grab that prefix, and you don't have to manually search for the values which you are evaluating here. So for example, you mark this, and each of your log what you are logging will start with this, and then you grab it, and yeah, that's also a nice trick to make things more readable. So I guess that's it for the demo.